All right, good morning. Today what we're going to work on is we're going to continue on scatter plots, but we're going to continue with correlation, but now we're going to do a correlation coefficient and a line of best fit. So just a quick review. Again, a scatter plot is a graph of points with one variable plotted along each axis. So a recognizable pattern in the arrangement of points suggests a mathematical relationship between the variables. All right, so if we look at a scatter plot, so a graph of two data sets that may or may not have a relationship, they're similar to line graphs, but the points are not connected. So the points appear to be scattered, like in this graph right here. In this graph, you'll notice it's showing right here that the numbers on the y-axis, as they get bigger, and the numbers on the x-axis get bigger, it's going up. It's increasing. And that's where we reviewed that last time. It has a positive correlation, right? So positive correlation, the graph is going up diagonally. Correlation describes a relationship between the two data sets. We can have positive, negative. We can have strong, weak, or no correlation. In this graph right here, you'll see as my y values are decreasing, my x values are increasing. So this is a negative correlation. As my y values are going down, my x values are going up, right? The data points going up. And we'll take a look at more of that. So again, in this graph right here, we have positive correlation. Both data sets increase together, okay? Just to reinforce that. We've got that diagonal line would be going up. Negative correlation as one data set increases, so my x is increasing, the y values are decreasing. So when I'm at an x value here, or a small x value, I have a very high y value. The further I get out, the larger my x value gets, the smaller my y value gets. And in this graph, we have no correlation at all. It changes in one data set do not affect the other data set. So this is, the data points are definitely scattered in this one right here. All right, so now to move on to new material. So our correlation coefficient we represent with the letter R. Correlation coefficient varies from -1 to +1. So the sign of R corresponds to the type of correlation. Is it positive or negative? So that sign in the front tells you, are they both data sets are increasing together? Or if it's negative, if I'm at a -1, one data set increases as the other decreases. So the number that we put to it indicates the strength of the correlation. So a strongly correlated data point, or strongly correlated data points look more like points that lie on a straight line and have values closer to -1 or +1. Asking, so, and if they have no correlation or a weaker correlation, they're going to be closer to 0. Is asking if two variables are correlated is a question about whether or not there's a relationship between them, right? So if we look at right here, we've got strong correlation, right? It looks like this graph, most of those points look like they're almost lying directly on that line. So the correlation coefficient for these, the R would be equal to about 1, right? So correlation coefficient, and let me just move this up, sorry. So our correlation coefficient is close to 1. So it's very good correlation. All right, just going to copy this box, put it right here. So in this one, we had to guess at this one. It's not 0, right? They're both increasing, but it's not 1. Those points are further apart or further away from that line, that trend line that runs through them. So this would be probably more like a 0.5 for our correlation. Again, if we continue with this, this third graph shows basically we're not really seeing a whole lot of a relationship here. The dots are just all over the place. So this has a correlation coefficient that is close to 0 or is at 0. Our fourth graph is where we have, now we've got, as the x is increasing, our y is decreasing. So when our x is small, we have a very large value for y. But as our x gets much larger, our y value is much smaller. So this would be a correlation coefficient that's negative. But again, like if we look at those points, they're not on that straight line, that trend line. So they're more like a negative 0.5. And then this last graph is again negative. But the data points are pretty much right on or right around that trend line that's going down. So this is more of a -1. So this is where -1, if it's getting close to -1, we have a strong correlation coefficient or strong correlation. Negative 0.5, it's a weak. If we're not able to show that it has any correlation, it has zero correlation. These where they're pointing up have a positive correlation, but this one where the data points are off of it, it's a weaker correlation. It's about a 0.5. And this one where the data is almost right on that line, we have a strong correlation because it's pretty close to 1. All right, so if, for an example right now, I'm going to stop this on Edpuzzle. You guys will answer this question. So I want you guys to estimate what you think the correlation coefficient for this scatter plot would be. So the scatter plot, again, shows whether two sets of data are related. This scatter plot shows data about a child's age and his or her shoe size. By looking at both, you can see if there is a relationship between the two sets of data. So I'm going to try to draw a trend line through this. If I had to go like that, what would you say? Is that positive, negative? Is it strong, weak? And I'm going to stop and ask you the question right now in Edpuzzle. All right, now that you're back, I'm going to, again, have you guys just answer some questions about the below 3 graphs. So there's graph A represents this one. Graph B represents this. Graph C represents this. So I'm going to stop now on Edpuzzle. You guys will answer a couple questions about each graph, and then we'll come back for our last section on line of best fit. All right, so for line of best fit, line of best fit, two sets of data can be graphed as points in a scatter plot, just like we've been doing. If there is a relationship between the data sets, a line of best fit can be drawn. So a scatter plot is one of the best ways to show a correlation between two sets of data. A correlation is a description of a relationship. A line of best fit through a scatter plot is useful for making predictions. And so that's the most important thing is, now that we're able to prove, so we've got a couple examples again of positive, negative correlation, no correlation. But on this last one, you can see it's a strong correlation. They drew a trend line through it. And now the valuable part of this is with that trend line, now we can start making predictions about the data. So you'll see they drew this blue line going through the data. It's asking, can you predict the value of y? So what the value of y would be when x is equal to 30. So with that, we can just draw a line up. We hit the blue line, and then we draw a line up to the x-axis. We hit the blue line, and we draw a line all the way over to the y-axis. And you can see that when x is equal to 30, y will be approximately 10. So that's the value of this. The trend line helps us make predictions about our data. All right, so if I ask you this, which is the best trend line for the data shown? I'm going to have you answer that on Edpuzzle. Remember, with a trend line, we want it to run through the middle of the data, right? If I was to draw a trend line through this data, I don't want to draw it all the way down here. I'm not going to draw it all the way up here. I want to draw it right through the middle of the data, right? If I could draw a straight line on the computer, that would look awesome. But we want it to go through the middle of the data. So I want you to answer this question: which is the best trend line for the data shown? All right, and excuse me. I also want to answer the question on this one, which is the best trend line for the data shown as well. So I'll stop, ask the question at Edpuzzle. And then finally, we're going to calculate the line of best fit from the graph. So there's a couple different ways that we can do this. If we're just given the graph, we would have to do that by grabbing a couple points off. So let's just say, I put the data over here as well, but if I didn't have that data here, what I could do is first I'm going to pick a couple points. So I'm going to pick, and you'll see these go by ones on the x-axis and by twos on our y-axis. So it's always important to make sure you see what your scale factor is. X-axis, it's going by ones. So if I wanted to grab this one, let's say I wanted to use this point right here. All right. So I've got 6. And if I go all the way over from where I hit that line, I fall right in between, right? So if this is 10, that next tick mark is 12. The next one up is 14. So I fall in between 12 and 14, which is 13. So my first point off of this graph, let me see if I can draw this right there. So I'm going to have 6 comma 13. All right, and then if I was to pick another one off, let me go up to 30. And I'll see where that hits. So that hits here, and then it comes all the way over, and it falls in between 60 and 62, which would be 61, right? So on this one, I'm going to take another data point, and now it's 30, comma 61. So this is really, at this point, this is review of what we did earlier in the year. We're going to figure out what the slope is. So our first step is the slope. And then we find the y-intercept. And then we write our equation. Okay. So our slope is rise over run. So remember, it's y2 minus y1 all over x2 minus x1. Okay. So my y2 value I'm going to pick is 61. My y1 value is going to be the 13. That's all over my x2 value is 30 minus my x1 value is, or my my x1 value is 6. So I end up with 48 divided by 24. And we get 48 divided by 24 equals 2. Okay? So my slope is 2 on this. So now I have to figure out what is my y-intercept. So for this, remember, I'm just going to put in like y is equal to mx plus b. So in this case, let me make this a little bit bigger. So my m, or my slope, is going to be 2. So I could rewrite this as y is equal to 2x plus b. Now, I need to put something in. Like, I got to figure out what my b is, or my y-intercept. I have a y and an x. So where am I going to be able to get numbers for y and x? Well, if we look back, we have 2 points that we picked. Every point is represented by an x and a y. So what we're going to do is substitute in our value of, let me just get a different pen color. Our x coordinate is going to go in for the x here, and the y coordinate will go in for the y here. So when we do that, we get 13 is equal to 2 times 6 plus 1. All right, and when we do that out, I'm just going to put it over here so I can see it. So I said 13, 2 times 6 gives me 12. I'm sorry, this is plus b, not plus 1. All right, 13 is equal to 12 plus b. Now I got to solve for b, so I'm going to bring the 12 over to the opposite side. When I go to the opposite side of the equal sign, I use the opposite operation. So I'm going to subtract 12 from both sides. And we end up with b is equal to 1. So with that, I get my y equals mx plus b is going to be y is equal to my slope, which for m, which is 2x plus 1. So now if I said, all right, so this is the graph represents the number of cups of lemonade sold and how many dollars in sales you had. So if I said, let's say you made 60 cups or you sold 60 cups, how much money would you have made? So you're going to plug 60 in for x. So you'd go y is equal to 2 times 60 plus 1, right? So y is equal to 2 times 60 is 120 plus 1. So y, or how much money you made, is $121. All right? So if you're like, oh my God, Mr. Strang, that took forever. It's a long process. The other way, if you get the data on the table, or if you wanted to write all the data from the table of each individual point, so forget about the trend line, what you could do is use your graphing calculator. And I'm just going to pull that up. So if I go to stat, so I press the stat button, I want 1 for edit. I can hit 1 or I can just hit enter. And now I'm just going to enter, this is my L1 for my X and L2 is my Y's on my graphing calculator. So if I put that in, I'm going to go 5, enter, 10, 15, 20, 25, 30, 35. All right, and then for my L2, I just want to enter in my Y values now. So I'm going to go 14, 17, 33, 37, 56, 57, 73. Oh, there's my phone. All right, so now I put my data in, and now I want to see, can I get my my equation? So if I go back to stat, I'm going to go to calc. And which one do you think? I'm looking for linear or regression is what they call it, correlation coefficient. So if I look at number 4, linear regression, ax plus b, they should have used the mx plus b, but they didn't. It's ax plus b. So if I click 4, and then I just go, okay, enter, enter, right? I'm going to calculate it. So I get y equals ax plus b, a equals 2, b equals 1. So you'll see it's the same thing I did when I did my calculation, but using the calculator, the graphing calculator makes it much easier. So I got y equals 2x plus 1. So that's exactly what I got here. So I know it's been a long video. I'm just going to have you guys stop and do this last problem right here. You can do it either way. You can figure it out from the graph. The one thing, just make sure you realize the x-axis, we've got, it goes up by halves. The y goes up by ones. So, 5, 6, 7, 8, 9, 10. This goes 0.51, 1.52. So you'll be able to do that there. Calculate out what your slope and y-intercept is, and then tell me what the linear equation is. All right, that's all, and thank you.